In this lecture video, let us see the topic PN junction types. I'll explain you how a PN junction is formed and what happens when a PN junction is formed. In this lecture video, let us see the topic PN junction types. I'll explain you how a PN junction is formed and what happens when a PN junction is formed. This is a PN junction. A PN junction consists of a P-type semiconductor and an N-type semiconductor. A P-type semiconductor and an N-type semiconductor, they are joined together to form a PN junction. A P-type semiconductor has holes as its majority carriers and an N-type semiconductor has electrons as its majority carriers. However, there will be some electrons within a P-type semiconductor called minority carriers and holes in the N-type semiconductor called as minority carriers. As soon as a P-type semiconductor and an N-type semiconductor are joined together, the electrons from the N region will diffuse into the P region after the junction. Similarly, the holes from the P region will diffuse into the N region. This causes the charge carriers move from one region to the other, develops a voltage between the junction with a positive potential on the N region and a negative potential on the P region. And this potential is called as barrier potential. In this barrier potential, though it is assumed to have a voltage, basically for a PN junction, as soon as the charge carriers move from one region to the other region, the region will be completely depleted of charge. That means there is no charge in that region. Effectively, both the charge carriers will get cancel each other. And therefore, that region in which the P-type semiconductor and N-type semiconductor are joined can never be called as a P-type semiconductor or N-type semiconductor. Instead, it is purely intrinsic in that region. So we call that region as charges depleted. Therefore, this region is called as depletion region. In the depletion region, the charge carriers are depleted. That means there are no charge carriers within that region. This is the reason why, while you apply an external voltage, a potential difference between a P-type semiconductor and N-type semiconductor with positive potential applied to the P-type semiconductor and a negative potential applied to the N-type semiconductor. For conduction to happen, they require a voltage of around 0.6 volt if the PN junction is formed by means of silicon diode and 0.3 volt if the junction is formed by means of germanium element. And these voltages are similar to that of this barrier potential or almost equal to that of the barrier potential. So only if the barrier, a voltage more than the barrier potential is applied, the diode or the PN junction will start conducting in the forward direction. Otherwise, the PN junction will not conduct. Now, when the charge carriers which have already moved and these charge carriers moved from N region to the other side and P region to the other side, they are called as majority carriers. So these charge carriers moved from N region to the P region and P region to the N region are called majority charge carriers. Now, the minority charge carriers are also available on either sides. Because of the movement of majority charge carriers from one side to the other, as I told you, there is a barrier potential. This creates a field. And that field will cause the minority carriers which are electrons on the p region, to move from the p region to the n region, and the minority carriers, which are holes available in the n region, to move from n region to the p region, and this is called drift. And due to drift, due to charge carriers movement, there will be a current flow which is called as drift current. So drift current is a current flowing in the PN junction due to minority carriers. The majority carrier current is called as diffusion current. This is clearly explained on the next diagram. Electron drift from p region to the n region, and hole drift from n region to the p region. Electron diffusion happens from the n region to the p region, and hole diffusion happens from p region to the n region. Therefore, the majority carrier current conduction is due to diffusion, and the minority carrier conduction is due to drift.